So last time we met, we talked about solving a 3 by 3 system. How? How did we solve it? Substitution, okay? And when we solve by substitution, we isolate a variable, right? Isolate a variable, and then substitute it in somewhere else, okay? Does that make sense? You remember that? So today I'd like to show you how to solve a 3 by 3 system using elimination, okay? Using elimination implies what? What's that imply? So with substitution, we isolated a variable and substituted that variable, right? Elimination, we're going to eliminate a variable, right? Okay? Now, when we did elimination with 2 by 2s, we just eliminated one variable and bam, there was our other variable and what it equaled, right? It's a little bit more complicated with 3 by 3, but not too much. What we have to do is we have to eliminate a variable, the same variable, twice. Okay? So the first thing that we need to do is decide which variable we're going to eliminate. Now, some people struggle with this because this is one of those places where it doesn't matter. It doesn't matter if we eliminate the x's or the y's or the z's. Yes, sometimes some of them are easier than others. So we're going to talk about eliminating each one of these variables and what would happen. Okay? But other times, for instance, this problem, it doesn't matter. Pretty much one is just as easy as another one. Okay? So if we were going to eliminate the x's and we were looking at this bottom equation, what do you notice about this x in this bottom equation? It's negative, right? And don't we need one not positive and one negative? So that's a good start, right? So if I was going to use the middle equation and the bottom equation to eliminate x, what would I have to do to the bottom equation? Multiply it by 4. That's exactly right. What if I use the bottom equation and the top equation? What would I have to multiply the bottom one by? By 2, right? Does that seem relatively simple? So let's pretend that we want to eliminate the y's instead. What would I have to do if I was going to eliminate the y's? So we could multiply the top one by 5 and then combine the top two. And remember what I said, we've got to eliminate the y twice. We already used the top one and the middle one, multiplying by 5. What else would we have to do? Multiply the top one by -4 and combine it with the bottom one? Absolutely. Does that make sense? Could we eliminate the z's also? Like, could that have been our first choice, was to eliminate the z's? If we did, how would we eliminate the z's? Multiply the top one by 2 and add it to the middle one. And then in a separate step, multiply the top one by 3 and add it to the bottom one. Does that make sense? So we've talked about what to do for each variable. Did there seem to be one that may be a little harder than the other two? Yeah, because if we were doing the y's, we'd have to multiply by a -4 in the top equation, right? Do you want to mess with multiplying by negatives? Not if we can help it, right? And since the other two, it doesn't matter if we multiply, or we won't be multiplying by a negative, maybe y is not the best choice here. It is a choice, and we already know it's possible because we just talked about it. But let's choose either x or z. Which one would you like to eliminate? Z? Okay, so let's eliminate the z's. If I'm going to eliminate the z's, you told me a second ago I could start by multiplying the top one by a 2, right? If I multiply this one by a 2, can you even read that? Is that dark enough? Okay, hold on. If I multiply the top one by 2, what I get is 4x minus 2y minus 2z equals 30. Right? And what was I going to do with that? combine it with the middle one, right? The middle one is 4x plus 5y plus 2z equals 10. If I combine those two equations together, what do I get? 8x. Okay, so 4x and 4x is 8x. Negative 2y and 5y is 3y. Negative 2z and positive 2z cancels out, goes to 0, equals 40. Does that tell me anything? No, I can't know anything about that. I have one equation with an x and a y. What do I need? I need another equation with an x and y. That's exactly right. So that's why we said we've got to cancel out the z twice. Okay? So what else was I going to do to cancel out the z? Again, multiply the top one by 3. Okay? What you had to be real careful of, excuse me, is that you don't use the same two equations twice. Right? Because if I use the same two equations twice, I'm going to still get 8x plus 3y equals 40, and that's not going to help me at all. Okay? So we use the top two. Now I need the top one and the bottom one, right? Is that what you're telling me? Okay? So, but I'm going to multiply the top one by what? A 3. So if I multiply the top one by 3, and I'm multiplying the whole equation by 3, remember, what do I get? 6x minus 3y minus 3z equals 45. And then I have the bottom equation, negative x minus 4y plus 3z equals negative 20. When I combine those two equations, what do I end up with? What's 6x and a negative x? 5x. What's negative 3y minus 4y? Minus 7y. What's negative 3z and positive 3z? 0 equals 45 and negative 20? 25. Now what do I have? I have two equations with two variables. It's a 2 by 2. You guys know how to do that. Those are cinchy. Right? So what am I going to do? You want me to rewrite them together so that they're its own system? We can see a little bit easier. We have 8x plus 3y equals 40. And we have 5x minus 7y equals 25. Elimination or substitution at this point? Elimination, okay. Which variable would you like to eliminate? Is there one that's easier? Y's already have opposite signs. You're right, so maybe y's. So if I'm going to eliminate y's, what do I have to do? Times the top one by what? 4? 7 on the top? And 3 on the bottom? Is that what you said? I agree with that. So what's 7 times 8? 56x. What's 7 times 3y? 21y. What's 7 times 40? 280. What's 3 times 5x? 15x. What's 3 times negative 7y? Very good. Negative 21. What's 3 times 25? 75. When I combine those two, what do I get?
Miss Kingston?
Yes, ma'am.
Do you have Megan Burns?
I do.
Can you send her to the office, please?
Can she come in about 10 minutes?
Yes.
Thank you.
Thank you.
So when I combine these two, what do I get? $56x and 15x is what? 71x. 21y and negative 21y? 0. 280 and 75? Well, that's 5. That's 15. 355? So when I divide both sides by 71, what's x equal? Mm-hmm. 5. Good job. Good job. Now what? Now what? We want to substitute it in, right? We have x. Where do you want to put it in? Probably one of my 2 by 2 equations. That's a very great idea. Which one? So 8x plus 3y is what you want to do. Does it matter which one I put it in? But I'm going to do 8x plus 3y because that's what she said. 8x plus 3y equals 40, right? So x is 5, so 8 times 5 plus 3y equals 40. What's 8 times 5? 40 plus 3y equals 40. Subtracting 40 from both sides gives me 3y equals 0. So y equals 0. All that work for nothing? I mean, I guess that's true because 0 is nothing. But, yeah. Right, I know x and y, so I'm going to plug both of them in. Where? Into one of my original equations. Does it matter? So choose one. Top one? Okay. So 2 times x, which is 5, minus y, which is 0, minus z equals 15. So 2 times 5 is 10, minus 0 minus z equals 15. What's 10 minus 0? Oh my lord. 10 minus z equals 15. So if I subtract 10 from both sides, I get negative z equals 5. Is that my answer? But I got z by itself. It's negative. That's not okay though, right? So z equals negative 5. So what's my answer? 5, 0, negative 5. Is it right? Well, we better check it, right? Okay. 5 times 2 is 10. 10 minus 0 is 10. Minus a negative 5. 10 minus a negative 5. That's 15, right? So we're still good. 4 times 5 is 20. Plus 5 times 0, that's still 20. Plus 2 times negative 5, so 20 minus 10. It's 10. It's all right. So negative 5 minus 0, so negative 5. Plus 3 times negative 5 is negative 15, so negative 5 and negative 15. Negative 20, is it right? How are you going to show me that it is? I'm going to check it. Questions? So let's talk back through this. Okay? I started here by eliminating z the first time. Right? Then I went here and I eliminated z again. Right? And then I used these two equations that I had eliminated z in and eliminated a variable. In this case, we chose to eliminate y. Once I found x, I substituted it back into one of these equations to find y. And once I knew y and x and y, I substituted it back to an original equation to find z. Questions? Easier or harder than yesterday? So that really depends on whether you like elimination better or substitution better, right? If you like substitution better, yesterday was fine. Today's maybe a little bit more challenging. Okay? got to press yourself to do better. Do your best. Okay? So if you're good with substitution, work on elimination. That's what we're working on today. Okay? Any questions? You have 3 problems to do tonight. Page 42 in your workbook, numbers 1, 2, and 3. If there's not enough room in your workbook for you to work, take a piece of paper and write it on your paper and just keep that paper in your workbook. Got it? You have the rest of the period to work. Mark, get set, go. Peace.